This video goes over a process for creating Anaglyph videos from 3D side-by-side video recordings that one can make on a MetaQuest 3. An Anaglyph is a stereoscopic 3D effect using color filtering on each eye. Anaglyph technology dates back to the late 1800s and started in still photography. While Anaglyphs don't provide as great of visuals as you'd get on a headset or with other newer 3D technology, they're still kind of a neat way to share 3D content with others using just a 2D screen and cheap 3D glasses. In this case, I'll be using red and cyan 3D glasses, generating a Dubois Anaglyph for 3D with color. First, your Quest 3 needs to be able to receive custom ADB commands, ADB as in Android Developer Bridge commands. To do that, you need to enable developer mode on your Quest 3 by installing the Meta Horizon app on a smartphone, creating a developer account, and activating developer mode. There are other videos on this procedure, so I won't get into those specifics here. I use SideQuest to send ADB commands. It can be good to restart your Quest 3 prior to issuing these commands so that everything is fresh and at default settings. I've sometimes run into visual glitches that were resolved by a restart and re-entering the ADB commands. The custom commands will stay active until next restart of the headset. I'm not claiming these are ideal settings or an ideal procedure. There are likely optimizations that can be made. These are baseline settings that work for me. Here are the commands I currently use to configure my Quest 3 to record 3D side-by-side video footage to be processed into an Anaglyph for watching on a 2D display at 60 frames per second using red and cyan 3D glasses. We're doing the following with these commands: setting the refresh rate of the headset to 120 Hz, setting the capture frame rate to 60 frames per second, capturing full frame rate, setting swap interval to 1 so every other refresh is captured, specifying to capture both eyes, setting the capture resolution to 3840 by 2054, which will be processed as a 1920 by 1080 Anaglyph video after some vertical cropping, setting the recording frame rate to 40 megabits per second for excellent video quality, setting CPU and GPU to high performance for the capture, setting the foveation level to 0 for uniform frame image quality, and forcing the settings to take effect. Once all those commands have been run, you can proceed with recording your content. For me, that would be playing some Pavlov VR. After done recording, copy your video to your PC. I use SideQuest for that as well. We now have a 3840 by 2054 side-by-side 3D video we need to edit and process as an Anaglyph. You can either convert the 3840 by 2054 side-by-side 3D video into a 1920 by 1080 Anaglyph and then edit, or you can edit as a 3D video and then convert it to an Anaglyph. In this example, I'm going to perform the conversion to an Anaglyph first to conserve disk space while retaining best image quality. I'll be using FFmpeg to perform key video conversions. I acquire and copy FFmpeg into a folder along with my captured video file, and I run this command to convert the MP4 video file into a HUF-YUV losslessly compressed video, forced to 60 frames per second to address variable frame rates of recorded footage, center cropped to 1920 by 1080, and converted to a Dubois red-cyan Anaglyph. That will generate a very large output.mkv file, but that's okay because then we're going to edit and compress that output file. Afterwards, the large intermediate output.mkv file can be deleted. By using HUF-YUV, we're preventing an unnecessary recompression of the footage. If you're tight on disk space or you don't mind additional loss in video quality, you could opt to lossy compress the footage in the FFmpeg conversion command. The final part of this, at least for my own procedure, is to then import the generated output.mkv Anaglyph into Kdenlive, edit the footage, and then compress it as a high-quality WebM video. I like using VP9 in a high percentage quality setting. And here's the resulting video, which can be watched with red-cyan 3D glasses.